Hi, I am Jain, and today I'll be presenting the phishing detection system for websites on behalf of my team. So basically, we have used this PyCharm IDE, and we have used Streamlit for the deployment part. And our model is the multi-modal. Of course, we have used three models, and we have integrated them all together. So basically, we started with this LGBM model. Basically, we trained the model on the dataset. It is our own personal model, and like we trained around 8 to 10 models, including the boosting models, and out of them, the LGBM performs quite well. So we took this model, and here, like as you can see, there are around 28 to 30 features on which the model is being uh, used for prediction. Basically, we are extracting these 30 features from the URL, and for the explainability part, for the individual models, we have used different methods for explainability. So here you can see we have used SHAP. Basically, it emphasizes which features were important while the model gave the output, so it performs quite well for the explainability. And here, like, it works on a threshold. Like if the threshold is, you can see here, it was yeah. So basically, for the ML part, it is considered as phishing if it is greater than zero point 0.5, else it is legitimate. So closer to 0 means legitimate, and vice versa for phishing. And it works the same for LLM model. Like closer to 0, it means it is legitimate, and closer to 1 means phishing. So it works quite well. And after that, we have used this UI comparability. Basically, what happens is we have used Selenium in this. So the Selenium automatically goes to the URL. Like the if the user inputs the URL, then the Selenium will go to that URL, fetch the screenshot, and compare it with the screenshot that is already stored in our database. You can see here. So yeah, these are only the 5 images for the reference part. So it works, so it performs quite well. We have used the hashing algorithm, so it hashes the whole image, and then it compares the similarity between the two images. That is the one factor. The second factor is the color. It sees the overall color of the image, the color mixture and everything. And the third is the OCR. Basically, we extract the text from the image, and then we compare like how the text are similar, like how much the text are similar. And we have used pytesseract for that. And this app1.py contains the UI part. This app2.py contains the part where we have integrated both the ML model and the LLM part. So basically, it gives around zero point 0.6 to ML and zero point 0.4 to LLM. And after that, this is the main Streamlit file. Basically, we have integrated all the two. So basically, that sums up to all the three. And wait, I'll just show you the functioning. It takes some time. Till then, I'll show you the weightings. So basically, first, like I'll show you the weights. Basically, for the our own personal model, which is LGBM, we have weighted it to around 50%. For LLM, it's 30%, and for UI, it's 20%. And we have also used reweightings for like reweighting if the UI is missing, or for some reasons the UI, like the link is not accessible, or the Selenium is not working, or for some other reason the UI is not working. So it will reweight accordingly to LGBM and LLM, like 62.5 and 37.5. Something like this will be reweighted. So it performs quite well. And here, like as I told earlier, that closer to 0 means legitimate, and closer to 1 means phishing. So we have renormalized it, because for the UI, closer to 1 means legitimate. So it was clashing, so we normalize it. And now for every model, for everything, closer to 1 means legitimate, and closer to 0 means phishing. So we have used this kind of logic here. So for the LLM, like I'll explain you how the LLM is working. So for that, like we have used this Mistral, like we have imported it from Ollama. We have pulled it from Ollama, and it's a small model of around, I guess, 4.5 GB. And basically, it works by taking the content from the website. Like basically, we are using beautiful from BS4, and we are extracting around 2,000 tokens from the website, and we are feeding it to this Ollama, this Mistral, and based on that it gives the output if the website is phishing or not. And we are also giving the domain link to the website, to this Mistral model. So eventually its accuracy increases. So yeah, that sums up of this Ollama. Now I'll show you the working. So this is our interface. Basically, you can see, and here I'll show you for one legitimate website, that is PayPal. So as you can see, this is our own model, which gave around 80% accuracy for legitimacy, and for LLM it's also 80%. So basically how this LLM part works, I'll explain you in detail. So we have hard coded three values, like if it considers the link to be very suspicious or very close to phishing, then it gives the score to around zero point 0.2 and zero point 0.3, something like that. And if it consider like if the model is confused about the link, then it gives the score around zero point 0.5. And if the model considers it to be safe, then it gives the scores zero point 0.8. So by using this logic, it performs quite well. And after that, this is the explanation using SHAP for the LGBM part, and this is the reasoning for the LLM. And LLMs are quite good in explaining their reasons, so there's no need to integrate such explainability for the LLM. It works quite well like this only. And after this, the module 2, you can see the UI part. The image, like I have used the original domain link, and we have the image stored in our database, so the image matches to 1, the text also matches to 1, then the color is also somewhat 1. So you can see here also we have, like I have used weighting. The image is being reweighted to 0.5 50%, and the color is reweighted to 40%, and the text is reweighted to 1. So basically this is our total score. And after that, this is the combined final analysis where I told you the weightings 50, 30, 20, and this is the graph we got. So this is the threshold 0 0.5. So above threshold means the legit, like if the link is legit, and below threshold means the link is phishing. So you can see it performs quite well. It gave around 83% accuracy for the legit website. So this sums up everything for the legit website. Now I'll show you one example for phishing. So I have taken a website, basically phishing website. This from the fish tank. This is the website where you can get all the links for the phishing. And now I'll show you the running for it. So as you can see, the prediction has been given by the models. For LGBM, it's showing 0.28% legitimacy. This is a legit score we are getting. So it's quite low. So it has predicted it phishing. The legit score for the LLM is zero point 0.5, so it is considering it as phishing. These are the explainability that I showed you earlier. So for this, we don't have any reference image that it can be compared to. So the no reference found for Elergo and whatever website we have given the input. So it has done the reweighting, like initially it was 50% to this LGBM and around 30% to this LLM. So the reweighting has been done correctly, and you can see that it is working quite well. The final score is phishing, it is below the threshold. So yes, this sums up our total project.